Okay, so there's 6 types of factoring that we're going to look at to start, and these will be some of the main things that you run across when you're trying to factor a polynomial. So the first one is one of the most simple ones, and that's because it has no greatest common factor and the leading coefficient is 1. And what I mean by that is no common factor is, if you notice the numbers out in front, they're not all divisible by the same thing. Like, you don't have some number that they're all divisible by. And if you look at the variables, the letters that are on there, there's no common letter. Well, there is an x squared, there is an x on the second term, there's nothing on the third term. So we don't have an x on each one of them. We don't have a common number we can divide each one of them by. So that's what I mean by no greatest common factors. Nothing we can factor out or divide out to make this smaller and easier to work with. And the leading coefficient is 1. What I mean by that is that the leading term, this x squared, when written in standard form, there is a secret hidden 1 out in front in there. And because of that, that's what we mean by the leading coefficient is 1. And when we have that scenario where the leading coefficient is 1, it's actually pretty easy to factor. What we're going to do is we're going to look at the last term here, and we see that it's positive 20. It's important to recognize that it's positive 20, because if this were negative 20, we'd be looking for a different set of numbers. So what I'm looking for are 2 numbers that multiply to make this number. And the same 2 numbers, you can't switch 2 numbers, the same 2 numbers will add to make this one. So when we factor, what we're doing is we're breaking it down into 2 things that will multiply to make that polynomial. So what I'm going to do is start 2 parentheses, because when we've got 2 things in parentheses, they're being multiplied together. So since we have x squared, we're actually going to split that up. If that were a, I would split it up into a and a. If it were n squared, I would split it up into n and n. If it were h squared, I would split it up into h and h. But this is x squared, so I split it up into x and x. Now, again, I'm looking for 2 numbers that multiply to make positive 20, that add to make positive 9. Well, the 2 numbers I can think of, I could do 1 and 20, but I don't think adding 1 and 20 is going to get me to 9. The other option is I could use the negative versions. I could use negative 1 and negative 20. That would be positive 20 as well when multiplied together, but that's not going to get me to positive 9. So it's probably either going to be positive 5 and positive 4, or it could be negative 5 and negative 4, because both of those will make positive 20. The difference being when you add the top ones together, you get positive 9, and when you add the bottoms together, you get negative 9. And since I'm looking for a positive 9, it must be the top ones. So I've got positive 5 and positive 4. X plus 5, x plus 4. To test this, I'm not going to do this for every one, but to test to make sure that this is the correct answer, I am going to FOIL it, which is like going backwards from factoring. Factoring and FOILing are like inverse operations there, that we are going to FOIL it. And that stands for first, outer, inner, and last. And it tells us which ones to multiply together to find out what this polynomial looks like. So I'm going to do the first term times the first term. So I'm going to multiply those things together. X times x is x squared. Then I'm going to do the outer ones. And I mean, it's like if you've got 4 things written there, 4 terms, I'm looking at the ones that are on the outside. These 2 are on the outside. So x times 4 or 4 times x is 4x. So I've done the first, I've done the outer. I'm going to move to the inner, which are the 2. If all 4 are written, the x and the 4 were on the outside, the 5 and the x are on the inside. So 5 times x will give me 5x. And then finally the last, which will be the last term in the first set and the last term in the second set. 5 times 4 gives me 20. Now there are 2 terms there that can be combined. We combine our like terms, 4x plus 5x. That will give me 9x when added together. So we end up with x squared plus 9x plus 20. This is me checking my work there. So really my answer when factoring it was this right here. Everything below it was me just verifying that that answer was correct. So I was like, is this the right answer? It sure is, because when I multiply it out, I get x squared plus 9x plus 20. So this is the scenario that you're going to use every time that you've got no greatest common factor. There's no number or letter you can factor out of all three terms, and the leading coefficient is 1, which means, again, that thing right out front of the x squared, when it's written in standard form, meaning the biggest power comes first, our x squared, then our x to the first power, and then we have no x there. So we've got that written in standard form. There's a leading coefficient of 1. This is the method we are going to use for that one. Okay, our next scenario is what if we do have a greatest common factor? So there is something in common with all of these. Once we factor that out, we're going to make our polynomial a little bit easier to work with. And in this example here, you're going to see that after we pull out the GCF, we are going to have a leading coefficient of 1, meaning that where that 6 is in the beginning of the problem, that will become a 1. So what I'm going to do is I'm going to look at all three terms and see if they have something in common. And I go something, maybe a letter, a variable, maybe they've got a number they can all be divided by. And I see the first one's got a 6, and I go, well, maybe they're all divisible by 6. So I'm just going to check that. 6 goes into 6, 6 goes into 12, and in fact 6 does go into negative 210. So what I'm going to do here is I am actually going to divide out a 6. So I'm going to pull that 6 out front, and it's kind of like what would be left if I divided each one of these by 6 there. So here those 6's would cancel out, and I've got v squared. On the center term, I would end up 6 goes into 6 once, 6 goes into positive 12 positive 2 times. I would end up with positive 2v. And then finally 6 goes into 6 once, and 6 goes into negative 210 negative 35 times, because 6 times negative 35 will give me negative 210. So I'm going to write that negative 35 there. Now that's 6 there. Don't lose it. It's going to be written in my final answer. It stays out front. But now I've got a 6 out here. And like the last problem, this area that is in parentheses here now has a leading coefficient of 1. It's got nothing in common. I can't factor anything out of there. So what I'm going to do is I'm going to factor what is in the parentheses just like I did the last one. That 6, it's going to stay outside, part of the answer. But everything else, we're going to keep going this way. So again, I am going to look for two numbers that multiply to make negative 35 that add to give me positive 2. Well, I could, if I'm going to get a negative number, I know that the two things that are being multiplied, that one of them is negative and one of them is positive, because a negative times a positive will give me a negative. So let's say I pick something like negative 7 and positive 5. If I multiply those together, I will get negative 35. However, when I add those two things together, negative 7 and positive 5, I'll get negative 2, which does not match that center term there. I need it to match. So I go, oh, wait a minute. Instead of doing that, what if I do a positive 7 and a negative 5? Multiply those two things together, and I still get negative 35, but now because the positive number is more positive than the negative number is negative, there are more positives than negative, it's going to end up positive, which I need. So I need a positive 7 and a negative 5. Now remember, on the last problem, I had x's, so I started each one of these with x's. This is a v. There are v's in this one, so I'm going to start these with v's. Now, the two things I'm going to put in there are positive 7 and negative 5. Now, it doesn't matter which order I put these in, because sometimes people are like, well, what if you had put this, v minus 5 and v plus 7, which is the same thing that's up above, just in the opposite order. They just switched here. So keep my 6 out front. Same thing. If you think about it, 7 times 5 is exactly the same as 5 times 7. They work out exactly the same because when you multiply, the order in which you multiply things doesn't matter. So to check it, we're going to FOIL it out here. First, outer, inner, last. Now, I'm only going to do that for the part in parentheses first. I'll do the 6 last. You can do it in whatever order you want. Me, I like to get my foiling done right away. So I'm going to do the first term in the parentheses times the first term in the parentheses, which is v squared. Now I'm keeping all that separate from my 6. My 6 is still out front. Now I'm going to do the outer. So the v is on the outer and the 7 is on the outer, so I get 7v. The inner, I've got negative 5 and v, which is negative 5v. And finally, the last term in each parentheses multiplied by the last term in each parentheses. So negative 5 times positive 7 is negative 35. Close my parentheses. That 6 is still out front. I am going to do just like the last problem, combine like terms, and I've got 6 times v squared plus 2v minus 35. Now, everything that you're seeing in red there is just me checking it. My final answer is really going to be right here, as long as it checks out. If I check out and all this work looks good, then that is my answer. That is the factored version. But this is, the steps in red are me checking my answer to go, okay, well, I think that's it. I'm just going to verify now by working backwards to verify it. So last but not least, I have that 6 outside. I'm going to work it back in to see my answer. I'm going to distribute it to each one of those. So 6 times v squared is 6v squared. 6 times positive 2v is a positive 12v, and 6 times negative 35 is negative 210. Since my check matched my original that was up there, it means that my answer, which is right here, this is my answer, that it is the correct answer. When I multiplied it out, it took me right back to the beginning. So the factored version is kind of the broken down one. Everything in red, again, is just the check. All of that is not necessarily your answer. It's just the check for your answer. Okay, the third scenario we have is where there is no GCF. There's nothing you can factor out, and the leading coefficient is not 1. There's really 2 different methods that we can use. Well, there's more than 2 different methods, but the main 2 methods that people use at this point are there's one that we call guess and check, which is generally a little bit faster if you have good number sense, if you know your numbers and what multiplies to make what. If not, there is kind of a more formal method that some people call the British method. It takes a little bit longer, but it will kind of, if you're stuck on numbers, it'll always kind of get you there, but it can take a little bit longer. So I'm going to go with the guess and check method first. So one of the things I'm going to do is I'm going to notice when I get here, I'm always going to check to see if there's a GCF. That's always the first thing I do when I try to factor something. Is there a GCF? No, there's no number that goes into all 3 of these. They don't each have an N. So the only other thing I do is I look and I see, well, the leading coefficient is not 1. So what I cannot do is I cannot go what 2 numbers multiply to make positive 54 that add to give me negative 69. That is not possible on this one. So here's what we're going to do that's a little bit different. What we're going to do is we're going to create those 2 parentheses just like we did before. And we're going to use kind of like the idea. So we're going to do the guess and check method first. And we're going to kind of use that property of foiling to make some decisions. So when you foil, you do the first term times the first term. And when you do whatever this guy is times whatever this guy is, when you multiply them together, you end up getting this. So whatever 2 numbers I'm going to put in those little slots there, I need them to multiply to make 7n squared. So I can pick any 2 numbers that I can think of that multiply. So I'm going to look at the number and I'm going to look at the letters, but together it needs to make 7n squared. The only things I can think of to make 7 are 7 and 1. That's the only combination of whole numbers I'm going to find. And n squared, I'm going to break that up into n times n, because n times n is n squared. So I'm just going to break that up into 7n and n, because those 2 multiplied together will give me that 7n squared. So that's where the first 2 are coming from. Now, when it comes to the 54, that's going to give us this term right here. But there may be more than one combination that will give me 54. So I am looking for 2 numbers that multiply to make positive 54, but they don't have to add up to negative 69. So what I'm going to do here is I'm going to pick something incorrect. I'm going to pick two numbers that are not the answers. But this is guess and check. So this could very much be like, these are the numbers I could have tried. So the first numbers I'm going to try are 18 and 3. So I know that the two numbers, when multiplied together, have to be a positive 54. So either 18 and 3 are both positive or they're both negative, because two negative numbers will give me a positive, or two positive numbers will give me a positive when multiplied together. But then I notice that they add to a negative 69. So two positive numbers are not going to add to a negative number, but two negative numbers might. So I'm going to try negative 18 and negative 3. So I'm going to put them in some order. Now, I would say the order doesn't matter, but actually the order very much matters. So the answer could be completely different. I'm going to try negative 18 right here, and I'm going to try negative 3 right here. And I go, well, maybe that's my answer, because those two things would give me my 54, and they would give me my 7n squared, but I don't know whether they'll give me the negative 69n. So I'm just going to check that. Now, the way you can check it is you could FOIL everything out. That's true. We already know that it's going to make the first one. We know that it's going to make the last one, because that's how we got these terms. So the middle term comes from the outer ones being multiplied together and the inner ones being multiplied together. So if I check those, that's what's going to give me an idea. So 7n times negative 3 is negative 21n. And then I've got negative 18 times n, which give me negative 18n. So I'm just going to combine like terms now, and what I get is negative 39n, which is not the negative 69n I needed. So this would not be the answer. But maybe I just have the negative 18 and the negative 3 in the wrong place. So I'll go, okay, I'm going to go back up here, and I'm going to try swapping them. So again, this was not the correct answer. So let me just put a little red X there to verify. This guy, not the right answer. But maybe if I make a little change. So I go 7n minus 3. I go, okay, and maybe the negative 3 went with the 7, and I go n minus 18. I still know that the 7n squared is going to work, and the positive 54 is going to work, because that's how we got those numbers, but I still need to check whether we get that center term. So I'm going to start with the outer and inner terms, just like we did on the last time. So we're going to check to see whether it's going to make negative 69, is that here, 7 times negative 18 is going to give me negative 126n. Negative 3 and n will give me negative 3n. This is not going to be negative 69n. This is negative 129n. So in any order, this was not giving me the right one. So this is not it either. And I go, okay, that's why we call it guess and check. You are guessing numbers and checking numbers. But I go, well, if I think about it, if I just think about my times table, so there were probably two better numbers to use that maybe I'd be like, well, let me try the ones that are in, like, you know, like if you go all the way up to 12 times 12, you can get two numbers that multiply to make 54. So I'm going to try my 7n and n. I'm going to keep those. And I'm going to try 6 times 9, because 6 times 9 is 54. But remember, I need the negative versions, because negative 6 times negative 9 is a positive 54. And when I add two negative numbers together, I am going to get a negative number. So let me try those. So let me try 7n minus 6 and n minus 9. I already know it's going to give me the 7n squared, and I already know it's going to give me the 54, because those parts, that's kind of how we came up with this. But what I don't know is whether the outer and inner term will be correct. So that's what I'm going to do. I'm going to try the outer term. This becomes negative 63n. This becomes negative 6n. Together, they become negative 69n. So this is the one I'm looking for. So it is guess and check, and hopefully you went for something like this first, but I wanted to do it wrong a couple times to be like, hey, listen, it happens. Sometimes you can't find the number. So hopefully you did this step correctly the first time and didn't go with the others, because most people aren't thinking 3 times 18. They're probably thinking 6 times 9 is 54. But I wanted to do it incorrectly to be like, well, sometimes we don't see it. So our final answer is this guy right here. that is the factored version. And we foiled it out and got here. Oh, I forgot my squared down there. And it matches what's up here, so we know that is the correct factored form. Again, this part here is the answer. That's the factored form. Don't turn this guy down here as the answer, because that's just where we started. We just went back to make sure that it worked. Okay, so in this next scenario, we've got, we will have a GCF, but the leading coefficient is not one. So similar to the last one, except for there is a GCF that we must deal with first. So I'm looking at the three terms that I've got there. Unfortunately, 25 does not go into each of them. That would be great if it did. It doesn't. However, I do notice that 5 goes into each of them. So if I were to divide everything in there by 5, divide this by 5, divide this by 5, and divide this by 5 so that I see what I have left over, I would have 5x squared. Negative 70 divided by 5 is going to be negative 14x. And then we've got negative 120 divided by 5, which will give me negative 24. So I still have that 5 out front. I do need to factor what is in parentheses, and I'm going to use my guess and check method again. Now, I've gotten pretty good at these over time, so you may not get it right on the first try. That's okay, just like we saw in the last one. I'm not going to keep making mistakes just to show mistakes. So here we go. I need something that multiplies to make 5x squared, and whatever that is, I'm going to put here. Two things. So I'm going to go with, how about 5x and x, because I can't really think of a whole lot more. I mean, I'm trying to split it up. So I get 5x and x. Now I'm looking for two numbers that are going to multiply to make negative 24. It's a negative 24. So I know that one of the numbers is negative and one of the numbers is positive. So I don't know which is which. So they could end up, it could end up going either way there. So I'm going to pick two numbers. I don't know. I mean, a lot come to my head. 2 and 12, 3 and 8, 6 and 4. I'll go with 6 and 4. So I'm going to go and let's do our negative 4 and positive 6. So I go, okay, well, let me see what I'm going to do here. I am going to play around with my numbers a little bit. And I'm in my head, I'll show you what I'm doing here in a second. I'm going to put my positive 6 here and my negative 4 there. Because I know that this positive 6 and the negative 4, when multiplied together, will make the negative 24. And the 5x and the x are going to multiply to make the 5x squared. But what I don't know is, will this make negative 14x? And that's what I'm going to check with the outer and inner. So I'm checking that now. 5x times negative 4 is negative 20x. And 6 and x is a positive 6x. Together they become negative 14x, which is what I'm looking for. So I end up with that will give me the correct answer. So it's going to end up negative 14x minus 24. There was a 5x squared to start this with a 5 outside. So my answer is the factored form, the most broken down one right there. So this guy is correct. I checked it down here, but really I should take it one more step and distribute to verify that takes me back to the original answer. So 5 times 5x squared is 25x squared. 5 times negative 14 is negative 70x. And 5 times negative 24 is negative 120, which matches my original answer. So I have checked that one as well. Okay, so the last two types of factoring that we're going to look at are factoring by grouping. The first one will have no GCF, so there's no common factor to factor out. We usually see these because they have 4 terms. If you notice, instead of 3 terms, what we're looking at is there are 4 separate terms up there. 1, 2, 3, 4, instead of the normal 3 where we have something being squared, something to the first power, and then something with no variable at all. So we can usually recognize these by they have 4 terms. It doesn't mean it'll always factor this way, but it's usually a likely candidate. So what we're going to do with grouping here is we're going to group 2 of them together and look for something in common, because all 4 of these have nothing in common. So we're going to put them into smaller groups and look for something that they have in common. Okay, so what I'm going to do to group them, I'm just going to actually rewrite this here. 28b cubed minus 4b squared. I'm going to take those first two, group them together, and then I'm going to take the second two, negative 21b plus 3, and I'm going to group them together in two separate groups. What I'm going to do is I'm going to look at the first two things and see if they have anything in common. Whatever it is in common, I'm going to pull that out, both a number and a variable. So I'm looking for the greatest thing they have in common. So I'm going to look at the numbers. Now, if this leading term, if this first one here were a negative, I would pull out a negative. I always want to pull out a negative in the beginning if I can. Now, there's no negative there, so I'm not going to. So I'm looking for what I can pull out of both of these. 4 goes into 28, 4 goes into negative 4, so that's a good choice. B squared goes into B squared goes into B to the third. So what I'm going to pull out is 4B squared. In that parentheses, I'm going to say what is left over after I divided each one of these by 4B squared. So the first one, I would have 7B and then minus 1, because if I divide negative 4b squared by 4b squared, I get minus 1. Now, these second two terms, I'm going to look for what they have in common, and I see that the two of them together, they start with a negative, so the first thing I'm going to factor out is a negative, because this guy is negative. Since it starts with a negative, I'm going to factor out a negative. Now, the only thing I can see that they have in common would be a negative 3. Negative 3 goes into negative 21, negative 3 goes into 3. So I factor out a negative 3, and then what I'm left with is 7b minus 1, because if I divided both of these by negative 3, negative 21b divided by negative 3 would be a positive 7b. Positive 3 divided by negative 3 would be a negative 1. Now, what happens here is if I've done this correctly, this will happen every time. These two things should match. If they match, which they should, we've done this right, and one of our factors, one of the two things we're looking for, is 7b minus 1. So what is in parentheses, I've got a 7b minus 1. Those match, great. So now the other factor is what's left over here. 4b squared minus 3. 4b squared minus 3. So this is actually the factored version of all this up here. Now, like most things, I'm going to go through and check it. And how do I check it? I FOIL it. So I'm going to go first times first. This becomes 4, that's not right. We've got 4 times 7 would be 28. B squared times B is B to the third. Now I'm going to do outer. Negative 1 times 4b squared would be negative 4b squared. The inner, which is negative 3 times 7b, which would be negative 21b. And finally, the last term in each times the last term, which would be positive 3. So I've got 28b cubed minus 4b squared minus 21b plus 3, which matches the original. Therefore, this is the factored form of it. That's great. That is my answer. All this down here is just the check for the answer. It checked out. It matched the original. Therefore, that is how we factor it. So factored is the broken down form. The one underneath it down here is just how we check it. Okay, the last one we've got is going to be grouping. This is with GCF, so we do have a greatest common factor here. There's a number, a variable, something that is common in each of these. In this case, I'm looking at all 4 and seeing what could I divide out of all of them. In that case, it is going to be a 6, so I'm going to put out a 6. Now, I'm going to kind of leave this 6 a little bit off to the side here so I don't get it confused with what the rest I'm doing. So there's a 6, and at the end, I'm going to have parentheses right next to it. So I'm just going to space it out here, and the only reason I space it out is so I can kind of not get it confused with what I'm doing over here. After I divide each of these by 6, after I factor that 6 out, I'm going to have 4n cubed. I am going to have negative 3n squared. I'm going to have 8n, and I'm going to have negative 6. Notice I've already put them in the grouping there. So I've grouped them together in hopes that I can multiply these out, because really what I've done, all I've done is taken out the GCF. This is not factored yet. This is still has more that's in common. If you notice, there's something in common in the first set of parentheses and something in common in the second set. So remember, there's a 6. I'm leaving the 6 way out front. That 6 I'm just kind of putting off to the side. So there's a 6 that will be in front of the answer. What I'm going to do here is I'm going to look at the first set and see in the first parentheses, what do I have in common? In that case, it looks like the only thing I have in common is an n squared. N squared goes into both of them, which would leave 4n minus 3 in the first parentheses. And then in the second set, it doesn't start with a negative, so I'm not going to pull out a negative. It starts with a positive. So I look at what number will go into both of these, and it looks like a positive 2 will go into both of those. So if I divide both of those by a positive 2, I get 4n minus 3. Again, these match, which is what I'm looking for in grouping, that they match. So I know one of my factors is 4n minus 3. How do I find the other factor? It's the other part that I didn't use, the n squared plus 2. N squared plus 2. And not to forget that I had this 6 waiting out there that should be out front. So this is the factored form right there. That's my answer. But as always, I'm going to check it. I like to do the foiling part first. You could distribute the 6 first, but I'm going to do this part first. So what I'm going to do is the n squared times 4n, which would be 4n cubed. I'm going to do, that's the first, I'm going to do the outer, which is negative 3n squared. I'm going to do the inner, which is 8n. And finally, the last times the last, positive 2 times negative 3 is a negative 6. And there is a 6 out front. I'm trying to see whether this matches the original one, so now I'm going to distribute to each of the things here. So 6 times 4n cubed is 24n cubed. 6 times negative 3n squared is negative 18n squared. 6 times 8n is positive 48n, and 6 times negative 6 is negative 36. And that's all the ways that we're going to do for now for factoring.